The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Thanks for joining us today. We're going to give this one more minute here, just kind of let some people trickle in, and we'll get going on our webinar here very shortly. All right, good morning, everybody. Thank you again for joining us. Today is going to be a little webinar where we're trying to educate our customers and future customers on what monitoring is. We've given people just enough time here to get in. So with that, we will get going. Like I mentioned, today's webinar is going to be going over monitoring for today's surveyors and engineers. And it's a pretty exciting technology, and I'm excited to share this with you guys. My name is Andrew Munson. I graduated from college in South Dakota at the South Dakota School of Mines and Technology. My focus was originally based around engineering, and it changed a little bit as I was going through college, but got a real good introduction to a lot of construction and engineering technology while I was there. Right after college, I graduated and went out and worked in the survey field for a little over 2 years. And after that, Frontier Precision was actually my dealer as a surveyor in the field. Dropped off a piece of equipment one day, and they had a wanted sign up for a job as an applied geospatial engineer here. I applied and got the job and moved out to Denver, Colorado, and started working for Frontier Precision in 2015. Over that time, I've had a few different roles here. I started as an applied geospatial engineer. And so what that meant was I was involved in a little bit of everything here at Frontier. So most of my day-to-day job was based around support and training. And it kind of gave me a real good exposure to all the different equipments that I sell, or that we sell here. After that, I moved into survey sales in Washington. Did that for a couple of years based out of Seattle. And it got a little bit more exposure to monitoring equipment. And recently, my wife and I had a kid, and decided that with having a kid, we wanted to get a little bit closer to family. And so I moved back to Denver, Colorado, and Frontier was able to find me a position here selling monitoring equipment. And it's been a good fit for me just based on the exposure that I had to equipment like this in the past. It's been a good year so far for me here in the monitoring world. On a personal note, like I mentioned, I just had a kid, so I'm a new father. You can hear I'm a little bit sick right now. I got a little bit of a cold I'm working through. After a week in daycare, my daughter decided to bring that sickness home and get the rest of us sick at home. So if you hear me take a little bit of a break today, it's probably because I'm in the background muted, trying to blow my nose here. So hang with me, and we'll get through this. So the first question that we have to cover is what is monitoring in general? And monitoring has really come to mean a lot of different things, but the most basic way to look at monitoring is really just the process of tracking change over time. And that change that we're tracking can be a lot of different things. It can be very traditional type data where we're looking for just movement. It can be data tracking angular change. It can be data tracking water levels and crack expansion and joint pressures. There's a lot of different things that this can mean. And monitoring means a lot of different things to different professionals as well. Frontier Precision is kind of always focused on the survey side of things. And so in our world, monitoring always meant you set up a total station and you let it measure the same point over and over again, and we track that movement over time. As technology has come out, as new technology has come out, we've started working a little bit more with more geotechnical engineers. And so the monitoring that they have done in the past is a little bit different than what surveyors are used to. And so monitoring really covers a very wide range of different things. This can be a fully automated process. It can be a fully manual process. So in some companies, as these projects are set up, and it is set up as a manual process, that means somebody has to go out to the field and take these readings and measure things and write things down and then plot this data manually. But the new technologies that we're working with has now made this to be a fully automated process. And so this completely takes us out of the field. Monitoring can now use a lot of different types of equipment. There's a traditional route of total stations and GPS receivers, and there's all these new geotechnical sensors that we will also cover today. And monitoring is very important because it does give us a total picture of what is happening on our job site. We only are able to see what we measure, and if we're not measuring it, we don't really know what's happening. And monitoring is what gives us that total control and total picture of what is happening on this job site. And these new technologies that we're using today makes this easier than ever. And it makes it very approachable for anybody else that wants to get into this line of work. The next question then is, why do we monitor? And the most important aspect of monitoring in many cases is really the safety aspect. And we're always looking at ways to improve safety out in the field. And monitoring is a very easy way to make all of our lives easier and safer. And that safety aspect could be because we're taking field crews out of dangerous areas. When we're looking at mines or open pits or busy roadways, we don't always want our crews out working in these areas. And so these monitoring equipment being fully automated can take those field crews out of these dangerous areas. And then once monitoring is set up, monitoring allows us to detect movement early on. And so as things are moving out in the field, we're able to see what is happening in the field. And then if we need corrective action to be put into place, this data allows us to know as soon as there is movement that we need to make some type of change on the site. Maybe that means taking people off of the job site entirely because there's been too much movement. But it really reduces the risk for people out on the job site, and it reduces the risk of potential failures with the structures that we're monitoring as well, because we know that movement is occurring as soon as it happens. Monitoring can also reduce our job costs. And this is something that's a little confusing to some people, because when we look at setting up a fully remote system, sometimes there are more costs involved in setting up these projects at the beginning. But then overall, as we look at the amount of time that people are traveling to job sites and collecting this data and manually plotting this data, those travel costs do add up over time. And so while there may be a little bit more upfront costs with a monitoring system, overall, these systems are able to reduce our overall costs for the entire job. And more data is always going to allow us to make better decisions. Being able to track change as it occurs is very important, and we're able to see how fast things are changing. And the more data we have, the more data that we can look at and rely on to see what is happening in the field. It's very important to know that we're only capturing whatever it is we measure. And when we have people manually measuring things, you're only capturing data at that single point in time, where these monitoring systems are set up to run extremely often. And so that does allow us to see these trends emerge and allow us to act quicker if we need to on these job sites. And then the third question is why should you monitor? This is something that a lot of people have failed to really look into, mostly because they don't know much about this type of equipment. But this is a very easy area for surveying and engineering firms to move into. You guys are already working on these projects. You might as well look for other ways to expand your offerings to your customers. And a lot of your customers that you are already providing survey and engineering work for, they are also needing more types of monitoring on site. And it's typically overlooked on these projects because we get so stuck in our lane, always focusing on our survey work or our engineering work, that we don't ever even read through the full set of plans and specs for a project. And a lot of the people that are already out doing this type of work for surveying and engineering, you are qualified to provide these services. You're already a part of these projects. You may want to look into potentially adding this on as a service for your customers. For a lot of these monitoring systems that are put in place, you already understand the background information and how these systems work. This just allows you to apply your knowledge and your skill set to another type of work out in the field. And there's sometimes actually where you might be able to use your existing equipment. So a lot of the upfront cost of installing these monitoring equipments comes with the equipment that you purchase. And if you already own it, we can really quickly reduce the overall install cost of this equipment and make it a very easy way and inexpensive way for you to get into the monitoring world. And there's been a lot of talk recently on infrastructure bills that are being passed by the United States government. There is a lot of money in that bill for our aging infrastructure. So things like buildings and structures and roads and bridges. There's a lot of money set aside for work to upgrade and improve on these structures that are existing now and they're aging and starting to crumble. With that, then, there's going to be a large monitoring aspect to a lot of these construction projects just to make sure that things are not failing too quickly. And while construction work is going on, it's going to allow us to kind of get in there and get a little piece of that pie. Overall, in that infrastructure bill, there's $550 billion that is going to be invested in infrastructure. And so over the coming years, there's going to be a lot more monitoring work coming available. And again, it's an easy way for you to expand your offerings for your customers. And so then that brings us to how we can help you at Frontier. In monitoring projects, there is a little bit of a startup time around these projects. It does take a little bit longer to get these projects going, but that's exactly what we're here to do. We're here to help you guys plan for these projects. We almost want to act more as a consultant for you because there's a lot of our customers have not done this before. We want to be able to almost coach you through and teach you and train you on how you can get into projects like this. So if you do come up with a project that you think you could provide a monitoring service on, just come to us, bring us the project specs, the location, and with that, we'll then help you plan what equipment needs to be used, what software you're going to need, how we're going to power the system, how all of our comms work. We can start looking at what types of data you're going to be able to get out of these systems. And then once we get to the point of getting ready to install this equipment, we'll help test all the equipment. And we can also offer install assistance if needed. So there's really quite a few different types of monitoring that is available currently to us in the field. And there's what we are calling our traditional monitoring. That's going to use things like total stations and GNSS equipment. And within traditional monitoring, then there is a fully automated option and there is a semi-automated option. We'll cover that here in a little bit. One of the newer offerings here at Frontier now is our geotechnical monitoring side. And this covers a very, very wide range of equipment that is available for us to use. And a lot of that data is going to be a little bit foreign to you. And so that's why we are hoping to be able to help coach you guys through how to use this data. But geotechnical monitoring is going to rely on different types of sensors that we install out in the field. And again, this covers a very wide range, but we could be looking at tilt meters that measure angular tilt and change. We could look at using laser tilt meters, which is going to use that same angular tilt sensor, but also give us a little EDM that gives us distance change as well. And then a large portion of geotechnical monitoring comes down to data loggers and hooking up different types of sensors in the field. And we offer data loggers in all different types of formats that allow you to hook up to different types of sensors. Those could be things like piezometers, load cells, strain gauge, pressure cells, extensometers. There's a very wide range of external sensors that we can hook up to our geotechnical monitoring systems. And so when we look at traditional monitoring, the semi-automated method is going to be one of the easiest ways for existing surveyors to get into monitoring. This lets you use your existing equipment that you already have. So you're going to need a total station, a data collector, and Trimble Business Center. Trimble has created a monitoring app right within Trimble Access, so it's going to be a very familiar workflow for you. And that monitoring app allows you to go out in the field, remeasure the same points over and over again, and generate some rounds. So when you go out to the job site, you hit a button, tell the total station to measure all of the existing monitoring targets out there. And once those targets have been measured, we're able to actually create some very simple reports right in the field so we can see how much these targets have moved over time. Once we're done in the field, we can then take that data into Trimble Business Center. Trimble has also created a monitoring module right within Trimble Business Center that allows us to track our changes, allows us to process the data, and then gives us a little bit more reporting options as to what things we need to see and what we need to present to our end customer. The nice part about these is these are not a permanent install. So again, you're just using your existing equipment, you're driving out to the site, and you're measuring targets over a certain amount of time. You know, this does require a little bit more time overall than automated monitoring, but it's a very low cost entry point for you. And so like I mentioned, you already have all of this equipment as a surveyor to do this type of work. You're just going to need your total station, your data collector, Trimble Access with that monitoring app, Trimble Business Center with the monitoring module. And then most times on projects like this, you will still install prisms that are going to be left on the structure that you're going to be working with. And these are often very little prisms. They're very inexpensive. You can either glue them in place or drill them in place and just leave them there. That allows us to measure the same point over and over again. It's really just a very easy setup, easy workflows, and easy report generation. Once we're done with the semi-automated monitoring, we can then start looking at moving into automated monitoring. And the first method we're going to look at is automated with GNSS equipment. This is more often going to be a permanent install of GNSS equipment, and this is used to track horizontal and vertical movement. It also tracks the speed of movement as well. So if you're looking at total trends in movement, the GNSS option is a very easy way to install equipment remotely and just let the equipment do its thing. The data is all post-processed within Trimble software, so it provides a very, very high accuracy solution, potentially down to the millimeter level of accuracy when it comes to tracking that movement. And this is very reliable equipment. You know, it's the same equipment that's powering most of our VRS networks and our CORS networks, so we know we can count on it. We know that it's accurate equipment, and we know that it's going to continue doing its job. When we move into automated, that does then give us 24/7 monitoring. So we have round-the-clock data coming in. And with that, then we also have alerting available 24/7. So if your GNSS receiver moves more than what you expect it to or more than what is allowed based on your project specs, you're going to get an email or a text message telling you that something is happening in the field. And so for these projects, you need to have some Trimble GNSS equipment. It is installed on site and left in place. Most often people are going to pour a concrete pillar or mount it on a building and leave that in place. We always need to have power for these systems. If there is direct 110 power, that's going to be a very easy way to get the system set up, but we can also look into solar options as well. Because these are remote systems, we don't always have access to power, and so we need to be able to have solar options available in order to power this. These are connected directly to a server over some type of data connection. You can then hook that up using a cellular modem or hardwired internet if that's available. So we got different options there. And then you're going to need Trimble's monitoring software. That is called Trimble 4D or T40. That software is hosted on a server. It can be a physical server. It can be a virtual server. We're able to work with you in whatever you have available to you. But that software is what is going to process your data, alert you to any changes, and then prepare these reports for you to send to your end client. We also then have traditional monitoring that is fully automated using total stations. And this is kind of the bread and butter of most monitoring customers. This is what most people are familiar with. And so this, again, is going to be a permanent install. A total station is going to be left in place. Your prisms are going to be left in place. And this is going to continually monitor and measure these targets throughout the day. And we can set it up on whatever schedule we want in order to do this. But this is used to track horizontal and vertical movement again. These total stations have been proven to be very reliable and accurate. You've used them in the field for years. This is just a new way to install this total station and leave it on site and let it do its thing. Just like the GNSS system, this is round-the-clock monitoring then, and it does give us round-the-clock alerting. The cool part about these systems is because it is a fully remote system, we are able then to access that remotely and measure new targets if we needed to remotely. We can look at the camera of the total station, view the site if we need to, and then any changes that need to be made to the system, we're able to do remotely from our office. So this is a completely remote, hands-off system once it is installed and in place. For these projects, you are going to need a Trimble total station. This can be an existing total station you have, or we can look at purchasing a new total station. When we're looking at total stations for monitoring jobs, we can look at actually reducing cost a little bit on that upfront total station cost, because we don't always need all the features that a robotic total station is going to need for your regular survey work. These, again, are typically installed on a dedicated pillar. It could be a poured concrete pillar. It could be a built pillar that you leave in place. And these are typically left outside. These are sealed against the elements, and so it's not going to damage the total station to be left outside. But we do also have options to put it inside of a housing if you're a little bit worried about snow or something piling up on top of these things. Just like our GNSS systems, these can be powered either by direct 110 power or a solar power system. And then these systems do require a different data modem than what our GNSS systems do. And we have a dedicated piece of equipment called the Set-Top M1. This unit is actually what's going to be your field data collector and your data modem. So this is what tells the total station to measure points, and it also is what sends data from the field to our server so we can track these changes. With that, then you do need to have either a SIM card available to put in there or have an Ethernet option available, so we can get data moving back and forth either way. You're also going to need that same software that we need for the GNSS project called T40. Again, it's hosted on a server. That's what processes our data and prepares our reports. And the prisms that we are going to be measuring are typically installed on site and left in place. And we do need back sites, just like we would in the survey world, to establish our accurate frame of reference. But then our monitoring prisms are typically these little L-bar prisms here on the right side of the screen that we just leave in place. Some of our more exciting technology that we're able to work with now are the geotechnical monitoring sensors. And Trimble recently partnered with a company called World Sensing or Load Sensing. This company has been in the field for quite a while. They have been offering sensors like this for quite a while, but this allows us to move from our traditional survey monitoring into a whole new world of monitoring. They offer sensors like tilt meters and laser tilt meters that we talked about earlier. And then their data logger line is what they have really focused on for a long time. And these data loggers are what allows us to connect a variety of other sensors and automate our data collection instead of sending somebody out to the field to read a manual sensor out in the field. And so the technology we're usually talking about when it comes to data loggers and the sensors that we connect to them are going to be vibrating wires, analog, or a digital data logger. So again, using these types of sensors, that does open us up to a whole new range of business here. A lot of the projects that are requiring traditional monitoring using a total station, they also typically require some type of geotechnical monitoring as well. And it's something a lot of us are not typically aware of because we've never had to focus on it in the past. A lot of the things that people are monitoring then are going to be your water levels and pressures on site. You can install strain gauges out on structures and make sure things are within spec. You could install extensometers to track cracks or movement overall. And this just makes it very easy for us to automate our data collection in the field. This equipment is installed and then left in place, so it's a fully remote system. And that data then again is automatically sent to a server that hosts that data. Our individual units are powered by batteries. And so again, they're totally remote, left in place. And those batteries are very long life batteries. You don't have to worry about changing these out very often. Typically, they'll last for many years left in place. And then there is a long range radio that connects all of our data loggers to what we call our gateway that handles all of our data collection. So if we look at this little chart here, on the left side, we have our data loggers and our wireless sensors like our tilt meters and laser tilt meters. Those all communicate over that long range radio to our gateway, which is this piece here in the middle. And the gateway then is what kind of collects all our data from our field units, packages it, and then sends it to our server. So that gateway does need some type of data availability, whether it's an Ethernet option or a SIM card. And then all of that data is sent to the server that is hosting our Trimble software, and that software then processes and alerts us to any changes that we see out on site. Just like World Sensing, we have another company of sensors that we are able to offer. This company is called Senceive, and they've been around for quite a while. They're based in Europe and are very popular over there in different types of monitoring applications, specifically in the rail industry. But they offer many of the same units as Trimble and World Sensing does. And so they have the tilt meters that pick up our angular tilt. They also have an optical displacement sensor, which is a tilt meter with a little EDM tracking that distance change. They also offer the vibrating wire, the analog data loggers, and they also have their own crack sensor node as well. So if we're worried about one crack spreading over time, these nodes are able to track that change for us. We have different sensors available for different installation requirements. So we have very discrete little sensors if you're looking at more of an indoor installation where we're worried about the aesthetics of these sensors. We have little ones that can be put in place and you'll barely even know that they're there. Senceive does offer two different types of radios as well. So depending on the project requirements, we may be able to use a different radio that may fit that system a little bit better. And just like the World Sensing units, these do have long life internal batteries. In this case, they can last up to 15 years left in place. So this allows us to do long-term monitoring with very little user input. So now we'll take a look a little bit more at what the specific pieces of equipment are from World Sensing. The first one here on the left is their wireless tilt meter. And this is a very high accuracy, high precision tilt sensor. So what this does is when it's installed in place, we're able to give it kind of a baseline reading or a zero position to start from. And then from that, we're able to track any angular change over time. And it's really easy for us to convert this angular change into a displacement type result. We're able to use very simple trig functions to track any displacement changes. And so by knowing the either distance between our tilt meters or distance from the ground to our tilt meter, we're able to calculate change just based on this thing measuring our angular tilt. The laser tilt meter does incorporate a little EDM. You can see that little window on the side of this tilt meter. That is going to measure a distance from this tilt meter over and over again and track that change. So if we're worried about, say, a wall leaning somewhere or a structure settling, this laser then is able to measure straight out from the sensor and give us that distance measurement over time. And it's very accurate distance measurements. It's repeatable down to the 0.15 millimeter range. So it's much more accurate than we'd typically be able to measure something with a total station and a man and a rod. They're very easy to configure. These are all weatherproof boxes, so we don't have to worry about these being installed outside. There are user replaceable batteries in these, and they have that long range configuration. And depending on how we are going to install these, we have an option to purchase these with an external antenna or an internal antenna. The external antenna is going to give us a little bit better range, but you're going to see the antenna sticking out, and there's always a possibility of that getting caught on something. So the internal antenna option does allow us to house everything inside of it, be a little bit more durable and a little less likely to be messed with. World Sensing is always focused on their data logger range, and they've got a very wide range of sensors able to connect to their data loggers. These data loggers are going to help us automate all of our data collection in the field. And because of the wide range of data loggers available, it it allows us to hook up to almost any type of sensor that we have out in the field currently. So we have our digital system, which is kind of one of the more popular new forms of data coming into these data loggers. We also have an analog system that measures electrical input and output. And we have a vibrating wire, which is kind of one of our more traditional forms of data acquisition. These are low power units. They have a long battery life. They're all powered by that internal battery, just like the other sensors we were looking at. And these offer a very high sampling rate, letting us collect data up to every 30 seconds, giving us the option then to really accurately track long-term data on our project sites. These use the same long-range radio as those tilt meters do. It's all inside of this weatherproof box, and again, it does support a very wide variety of sensors out on the market. From Senceive, again, we mentioned that they actually have two different types of radios that you can use depending on what your project is looking like. And so the first type of radio that's available from Senceive is called the flat mesh radio system. This is what we call a mesh network. And so all of the nodes that are collecting data all communicate to each other, and then they all communicate to a data logger. This allows us to do what we call intelligent monitoring. So if movement is detected, that can trigger the other sensors out on site to measure more frequently and give us more data input depending on what type of movement we're seeing and what type of change we're seeing. This flat mesh system is typically used when there's a lot more sensors being deployed in a very tight area. Most people report data about every 10 minutes with these systems. You can increase that a little bit if you need to. So again, it gives us a lot of data over the time period that we're monitoring. And these are fully remotely configurable. So once they're put in place, you can check these things from your office and make any changes needed from your office. Because this is a mesh network, the range between these nodes is not quite as long as some of our long-range systems, but it does still give us about 300 meters of range between each node. And then each of these nodes then act as a repeater. So, it might only be 300 meters between nodes that's available, but from the gateway that collects all our data, you can really look at extending that range out further and further and further just by installing more nodes out on site and collecting more data. Senceive also offers what's called the Geowan radio system. This is their long-range monitoring system, and it's a point-to-point network. So the data is going to send directly from each node right back to the gateway that's collecting all of our data. You can get up to about 15 kilometers between these gateways and nodes in very ideal conditions. So it's nice and flat and wide open. You can get these things out pretty far. These do report data a little bit less frequently than the flat mesh system did, but we can still get data typically about every hour. We can increase that again as well, but we start running into some issues with communication and battery life sometimes. But these, just like the flat mesh system, is remotely configurable, so you don't have to worry about going back out to the field to check on these. And this system is typically used when there are less nodes that are required, but it's covering a much longer range. Senceive has an entire line of tilt sensors called the Nano line, and you can see they've got 3 different sizes of sensors here. They all measure using the same sensor, so they're very accurate, very repeatable. They all have a very long battery life. Depending on the sensor that you go with and the size that you go with, that battery life is going to change a little bit, but you're looking at least 7 years of battery life out of each of these little tiny nodes. So once they're put in place, they will just continue to do their job. These all have an integrated temperature sensor, so we can track that internal temperature of these units, which gives us an idea of what's happening out on site. It's really easy then for us to correlate angular movement and change throughout the day with temperature changes. Because these are measuring so accurately, just temperature changes and the amount that temperature affects the structures that we're looking at, it just gives us a very easy way to correlate all that data. These are able to be mounted in any orientation, and they are weatherproof as well. They also have the traditional triaxial tilt sensor, which is on the right side of our screen here. Uses a very similar sensor to the Nano line, so it's very accurate, it's very precise, has another very long life battery, and works in the same way as the Nano line. We'll see these triaxial tilt sensors maybe mounted a little bit more in rail applications and in areas where we're not worried quite as much about the aesthetics of the unit. They do have the optical displacement node, so it uses that same tilt sensor, but it does give us the laser displacement sensor as well, so we're able to track that distance change. And then Senceive also offers an entire sensor interface range or an entire data logger lineup just like world sensing does. So if you have other sensors out on site that you need to be collecting data from, Senceive has these options as well. They have their own crack sensor node. They've got vibrating wire or the millivolt or analog type node. So we can connect to almost any type of sensor that you are installing in the field and make your data collection a fully remote acquisition system. Senceive also has a very cool option here called the Flexi Measure, and this is their version of an in-place inclinometer, and it comes in various sizes. You can see that there's 4 different sizes available up here of the Flexi Measure, and it's essentially the tilt sensors mounted inside of these flexible tubes that we can then install on a structure to track all kinds of different change. They're very lightweight. They're made of carbon fiber, so they're very easy to install. You can install them in any orientation depending on what type of data change you want to track. It's a very low power consumption, so we don't have to worry about having external power to get these things going. And they're very flexible, so when we mount these in place, you can mount them like in this picture. It's mounted around a tunnel, and this gives us a total idea of tunnel deformation. And they're waterproof up to 200 meters, so these can actually be installed in boreholes as well, like if you were tracking changes from in-place inclinometers that way. Senceive does offer their own software to track these changes. Their software is called WebMonitor, and it works very similar to how Trimble software works, where it tracks all of our data, it tracks changes, and it allows us to alert ourselves if there is any changes with our data. It gives you very easy to use graphs and charts to read. It's very easy for you to set up different alerts and different tolerances for each sensor if you need to, and you can have as many users use this as you want. That data from Senceive can all be sent to Trimble software as well, called T40. And T40 is a software that really brings everything together. So every single sensor that we have looked at and talked about today can all be integrated into one software called T40. This is what really makes our monitoring data powerful, because it allows us to automate our data collection, automate our processing, and then put it all in one place for us to view. It really lets you see all of your job in one place. From that data, then we're able to create multiple reports then within T40. Those reports can be automatically sent to certain users or certain project owners, and we can customize what is included in those reports. Very similar to our alerts, we can customize those alerts that are being sent out to users as well. They can be sent to different users based on different tolerances. So you may have somebody on your job site that needs to know as soon as any movement is detected. You may have somebody off the job site that only needs to know when movement has hit a critical level. And so we can set that all up within our system. Those alerts then can be sent out over email or text messages. And the nice part about the software too is there's unlimited users per license. So you can add as many people to this T40 license as you want, and they can all have their own level of access. So everybody can log in. Everybody might not be able to create new reports, but this is all configurable by the end user. You're able to decide what level of access you want all of these users to have. This is just a few screenshots of our T40 software, so you can kind of get an overview of your entire job site. This is just a map view here. It's pulling positions from the data that we're collecting and just putting it almost on like a Google Street View map. From that map, then you're able to look at each individual sensor and kind of look at what type of data is being measured. You can then click on each sensor and get a little bit more in-depth data from these sensors. There's different types of sensors available. So actually this picture here is looking at a tilt meter. This picture here is looking at a traditional target that's been measured, so a prism that's been put in place. From those sensors, then we're able to create charts that track our data and show us change over time. All of our axes are configurable, so you can choose how long of a period you want to look at. You can choose how close you want to be zoomed into this data to really track minute changes. And you can create charts that track all of your sensors as well. So this chart right here is tracking about 6 sensors overall and displaying different types of data all in one chart. Each of these types of data can then be turned on or off in the chart, so you can really look at individual pieces if you would like to. This is a picture of what our alert screen looks like inside of T40. So if there is an alert that's been sent out, you will get these different color-coded options here inside of T40 to let you know what has happened. This one right here is telling us that there has been no data collected. It looks like for 44 hours we have not gotten data. So that's the other nice part about these systems is even though it's fully remote, we have an idea of what's happening, whether it's movement that's been detected or a lack of data that's being collected. This system is going to let us know everything that happens. When there is an alert that's sent out, this is a picture of the email that you will get letting you know that something is happening on your job site. And so again, if we look at this, it's telling us that we have not gotten data here for over 24 hours. And so that's why we're getting these alerts sent to our email here. With each email, then you also get another one that allows you to then click on each alarm and alert that's come up and look at a little bit more detailed chart of what has happened as well. So all of this data is being sent directly to you as the end user and allowing you to track what is happening, even though you aren't on that job site. A lot of the power here with monitoring now is that we're able to connect all these third-party sensors, and it's something that we've never been able to do up until very recently. And so with that, there are a lot of different types of sensors that we're able to connect up, and this is just a little snippet of what we're able to use out in the field. So in this slide here, we have load cells that can be installed to detect changes in pressure. We've got water level sensors that are able to detect water rising or falling. You could install pressure cells that kind of track your settlement. We've got strain gauges that track movement on buildings and strain on things like pillars. You can use extensometers that track crack changes. There's settlement cells, crack meters, and piezometers that track all of our water levels and pressures and temperatures. So there's a very wide range of what is able to be connected out on site. And the nice part about all of the data loggers that we offer from either brand is that it doesn't really matter where they come from. They all speak a very basic language when it comes to sending that information out. And so we can connect things like a load cell from whatever company we want to our data logger. Our data logger is just going to read that basic information coming out of it and then send that data to T40 so we can actually look at what's happening out on site. Because there's so many of these available, we don't specifically support any one brand of third-party sensors, but we are in contact with a lot of companies that do sell these types of sensors. And so we can help you find these sensors if you need to, or we can help you integrate the existing sensors that you already have into T4D. A lot of people already have these types of sensors installed on site, and they're currently driving out to take a reading, write it down, and then track changes manually. We can integrate those existing sensors by just adding our communication equipment, so a data logger and a gateway, and automate all this data collection and keep you in the office instead of these return trips to the field. So now we're going to take a quick look at some different monitoring examples and kind of go over what we can expect this equipment to do. So buildings and structures, this is one of the more common uses for our traditional monitoring equipment. So if you look at all these pictures here, we've got total stations installed tracking building changes. So this is very common. This is one of the more common use cases for this equipment. And it can be installed in all different situations. So we've got some installed indoors here, so we don't have to worry about covering it too much. They can be installed outdoors where we've got some custom mounts built in some of these photos. And we are also able to help provide some of these mounting options as well. There's a whole range of accessories that we can provide with our total stations to help you install this equipment out in the field. It's very commonly used in transportation as well. You know, if we're tracking railroad movement, or if we're tracking bridge movement or tunnel change and deformation, or like this Lake Tahoe picture down in the lower left, we've got a bridge that is kind of right on the edge of a cliffside here. And so we're very cognizant now of any type of movement that is occurring out on site. This equipment installed in place is going to give us, again, that total picture of what's happening on our construction projects and make sure that we're able to do our job safely. We can also install either GNSS equipment or total stations in place to detect things like landslides and natural hazards. So these total stations will detect any type of soil movement or land movement very early on, so we can warn people either on the downside of that landslide area or potentially get in some type of remediation in place. So that's a very common use case for total stations and GNSS equipment here as well. we've looked at basically just total stations and GNSS systems being installed, but there are times when it's actually cheaper for us to install tilt meters on site instead of total stations. These tilt meters are significantly cheaper than installing a total station. They're very easy to put in place. And so there are times where it's easier for us to install tilt meters out on site. In this case here, this picture is actually showing us a combination of tilt meters that have been installed on site and load cells that have been installed on site. And so with the tilt meters up top, that's going to detect any angular change and let us know as soil or that wall starts to slip. And then the load cells are connected to our data logger line, sending our load cell data out to our server as well. So we can really get an idea of tilt at the top of the hill and pressures underneath the soil with these load cells. Senseive's line has quite a few examples of these tilt sensors being installed in place for landslide detection. So the way this system works is each of these sensors is installed. Each of these sensors is recording our angular change and sending data back to our gateway that is recording and sending and tracking all of our data changes out in the field. So if everything is going well, these will just continue to work and continue to measure and hopefully not detect any type of slide. If slides do occur, the sensors will still stay in place, still track all movement just like they did before. But as one of these nodes start to tilt, it can actually trigger the other nodes to start measuring more. This system is actually also connected to a camera. So as one node tilts, it will tell that camera then to take a picture. These would also track kind of your catastrophic failures as well. So just like before, if they're set up left in place, as things start to tilt, you'll see, as these start to detect tilt, they'll start to trigger the other nodes to start collecting more information. And if that catastrophic failure does occur, that camera can take a picture out on site, let you know what's happened, and hopefully then stop a train from hitting this material that's fallen onto the track. Water level monitoring is a pretty popular use case for our geotechnical monitoring nodes. So this project here, they were worried about borehole water levels near a dam. And so the piezometers were installed in these boreholes or in these pipes. They were connected to a world sensing data logger. And for this project, there was 29 of them installed on site, and they were all remotely collecting that data and reporting that data to the end user. And water level monitoring is probably one of the more popular geotechnical forms of monitoring available. It's another very easy one for our customers to move into because once it's installed and left in place, it's just going to continue to do its job and let you collect and monitor that data as it comes in. Rail monitoring has been a very big one for Senceive over the years, and specifically measuring track bed and how that track is changing. And it measures all kinds of angular tilt and change on the track. And the sensors are actually just installed right on the ties. Sometimes they're installed on the sides of the rail. Sometimes they're installed right down the center of the rail. But that gives us an idea of what's happening with our track bed throughout the day. So in this project here, there was actually 300 tilt sensors installed in place. They were installed on the track, but then also installed on buildings near the track. So as construction was going on, we were able to track whether or not that was affecting the rail. And we were also able to track whether or not that was affecting the buildings near the construction. And you're able to see here with a project like this that 300 sensors is a lot. That's a lot of install, but the sensors are so easy to install. They're already turned on, they're already powered, they already communicate natively to the gateway that you install on site, and you just glue these in place and move on. So you're looking at about sometimes up to 5 minutes to install each of these tilt sensors. But when you've got 300 of them, that gets to be a pretty big project. So that means big dollars for you to sell as a service to your customer. These tilt sensors here in this project came from Senceive to detect landslide again, just like the kind of animated example we were looking at earlier. These were installed on T-posts. So you just hammer this T-post in the ground, and that takes you 5 minutes. You mount the sensor on the T-post, and then this tracks any change over time. And so we're able to see that topsoil movement. And if there's been too much topsoil movement, that's a sign for us to stop trains from going down the track and keep them from colliding with this landslide. So it's very easy install, very reliable data that turns out to be very important data as well. Tunnel deformation is getting to be a little bit more common for monitoring as well, and this can be done either manually or automatically. It can be done with traditional methods like a total station, or it can be done with our geotechnical tilt sensors as well. And tunnel deformation monitoring gives us a total picture of what's happening inside of a tunnel, either during construction or even just during the lifetime of the tunnel, to make sure that it is structurally sound. And so for this project here, there was over 200 sensors installed throughout a tunnel, and it's a combination of tilt meters and optical displacement sensors. And so the tilt meters can be installed anywhere. They can be installed on the track. They can be installed on the walls. Those optical displacement sensors with that little EDM are typically then installed in a ring at specific stations throughout the tunnel. And so as the tunnel changes and moves, we're able to detect that angular tilt, but then with that little EDM, we're able to detect distance change as well. And so that distance change is really going to give us a total picture of how the shape of that tunnel is changing throughout our construction project. These inclinometers, they can be installed on structures. They can be installed in boreholes, but these inclinometers really give us a much more complete picture of how the structure is moving and changing. Because these sensors are all connected, everything is going to move then at the same time. So we know it's a continuous form of movement. And again, these can be installed in any orientation, but in this case, they were installed vertically to track our horizontal movement on the building. When we're looking at starting monitoring projects, there's always a few questions we need to ask before we get started. And this little chart over here on the right side does a good job of kind of walking through the different options for our more traditional monitoring methods. But we always need to look at what type of accuracy is required. Do we need a high-end total station, or can we get away with a lower-end total station? Do we need post-processed GNSS data or real-time data? Access to the site is always something important to know, because a lot of these we may only be able to get out there once or twice, and then you need an escort every time you get out there. So these remote systems allow us to continually measure without needing access to the site. And there's always different installation costs for each system. So that's something we always want to look at as well. We need to look at the total area that we need to cover when it comes to monitoring. Sometimes a total station can't see everything. So that's when we supplement our total station systems with our tilt sensors and really put together an entire monitoring system. And then we need to know if real-time answers are required. If we need real-time answers, that really means that an automated monitoring system is going to be the way to go when you're looking at providing monitoring services. We always need to look at how many things need to be observed or measured, whether that's water levels or pressures or just total amounts of prisms out on site. We need to know how often we need to measure these, so setting up a schedule to continually measure. We need to know what our power requirements are out on site. Do we have access to power? Do we need to bring our own power? And then same with communications. Most of these systems rely on a cellular system to send data back and forth. And so we need to know what type of cell coverage we have there. And if we don't have cell coverage, do we need to look at satellite internet options? Do we need to look at somehow getting a hard line of internet out there through like Ethernet? And then we always need to think about the theft aspect. The nice part about monitoring equipment is most people have no idea what this equipment is actually doing out on site. They just see something installed. They're not sure what it does. So most of the time it's left alone. But there's always a possibility that somebody is going to be a little bit more interested and may take this off the job site. So we do have accessories that would help kind of lock your equipment in place and keep people out of it. But it's always an important question. You know, and with monitoring, there's always complementary equipment that can go with it. And here at Frontier, we have a few different lines of equipment that we would call our complementary equipment to a monitoring system. So for some, that's just additional survey equipment. But for some people, that could mean things like underwater ROVs. And we have a salesman specifically here at Frontier that covers these underwater ROVs. These are very easy to use. They're used for more of an inspection type monitoring requirement. So you put these underwater, you control it with a remote control, and you can inspect whatever you have out on site. So when we're looking at maybe our customers that are monitoring on a dam and they need to see what's happening at the bottom of the dam, we can then kind of supplement your monitoring system with some of our inspection equipment as well. Frontier Precision does also carry in situ equipment, and we have a specific salesman here at Frontier that covers in situ. And in situ is some of our water level sensors, water quality sensors, and flow meters. A lot of this is able to integrate directly with the monitoring equipment that I sell as well. And so at Frontier, then we're really coming to you as a total team approach, trying to provide kind of your one-stop shop for all your monitoring and inspection needs. There is a full line of sensors that is supported, whether that be just water level or whether it's water quality. But again, we have a salesman here at Frontier that covers all this equipment. His name is Steve, and he'd be happy to help you out with any type of water monitoring questions. So what are our next steps then? Because monitoring is a little bit more difficult to get into, we want to be able to provide a service and help you guys get into this type of work. So even if we're just kind of doing very basic exploratory type discussions, just give me a call. I mean, that's exactly what I'm here to do, is to help you guys look at what we need to install out on site and how this equipment works together. So just bring it all to me. We'll sit down together. We can do it online, just do a little web meeting and look at your job site, what's needed on site, and how we can provide data for you. Here's my email and my phone number. You can either send me an email or call me. You could fill out a contact form through our website. But we're here to help you guys get into this type of work. We're excited about it, and we want you guys to be excited about it as well. We do have our own in-house monitoring system. So when we do get together for that meeting, we can then take a look at our monitoring system that's put in place and measuring around the clock. So you'll get a real life example of this stuff very close here to me. So just to kind of wrap this up, monitoring is going to be a major part of construction moving forward, and monitoring is becoming a requirement on nearly every project that we have been looking at. And there's a lot of different reasons for it, but particularly safety. And contractors are always worried about safety. This is a very easy way to guarantee that we're able to do your job safely and hopefully keep some of your guys out of the field and out of those dangerous situations. The nice part about monitoring is you're probably already qualified to take on these projects. You're already looking at these projects for one aspect of work. We might as well just try to kind of capture that next step on these job sites. And it adds another revenue stream to your business. It's very easy for you to get into. For the most part, it's very inexpensive to get into. And once it's set up, you're not touching it. So it's really just a good way for you to provide more services to your customer and make a little bit more money while you're doing it. There are a lot of different types of equipment to accomplish this, and that's why we want you to come to us with your questions and with your projects so we can look at what is going to fit your project a little bit better. The technology that's available to us today is making this easier than ever. We're able now to fully automate data collection that we've typically had to send people out in the field to do in the past. And we just want you to know that we're ready to be your partner on these projects. We can assist with the entire process, whether that's planning or purchase or training or install. We're here to help you through all of that. I've been kind of tracking questions over here on the back end. It doesn't look like we've gotten too many of them in here yet. So one question we had is, what is the operating temperature of these total stations? The nice part about these is they follow the exact same specs that our survey equipment does. So it works into the very, very low temperatures and very high temperatures. We can take we can look at that a little bit more in depth when it comes to time to plan for your project. But if you're able to work, the total station is going to be able to work. This is being recorded, so this will be available in some form for anybody else that wants to see this. And that takes care of our questions for today. You guys are familiar with Frontier Precision. We're really spreading out across most of the U.S. at this point, so if there's anything we can do to help you guys, don't hesitate to reach out. We've got offices all over the place to be able to help out. And that takes us to the end of our presentation. So thank you guys so much for coming today and taking a little bit of time to learn about monitoring. I will send a follow-up email out to all you guys just to make sure we're all on the same page. And if there's anything that I can do to help you out, please don't hesitate to reach out. Thank you, everybody.